Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. Today's video is brought to you by CAD File Explorer, the easiest way to see, manage, and clean up AutoCAD files in Revit. Get your free copy today by following the link in this video description. Let's see today how to use Revit and Dynamo to quickly convert your Revit rooms or spaces into this nice 3D space diagram. As you can see, these are fully interactive in 3D. I can have the diagram in perspective mode like this, or maybe in the traditional orthogonal mode, like in this other view here. You can of course be free to move things up and down. We will do this space diagram by level, so if I want to move the top floor a bit up, I can do that, and the same goes for the lower floors. If we now open a floor plan, for example, say level 1, you can see there, everything you see in 3D, it's just the 3D version of the rooms you have already created in your model. For example, this corridor here, that's the same object that this 3D diagram element is representing. This means whenever you update your rooms in the model, you can just rerun the Dynamo script, and this whole diagram will be updated for you. Also, you can choose which parameter to base the diagram on. If I now switch to Dynamo quickly, the script here you can just download from the video description, by the way. So if you don't have much time, simply go there and follow the link. Anyway, you can see at the moment I have used name as the parameter to color my rooms in 3D. But I can also change this to maybe department. Just copy the text there and run the script again. You can see there the colors have changed, so now all the rooms in the same department, they have the same color. Of course, the displacement effect is lost when I do this, but we can just quickly create the set again, move things up and down like this, and recreate the same diagram super quickly, using maybe a few more displacement paths like this to connect the levels very easily as well. I can of course do the same now in the perspective view, but it could be quicker if I just do this, undo the paths, change the view to perspective, and if I now put the paths back in, you can see there we have the same thing again, very quickly with the help of Dynamo. So let me show you right now how to do this in a few minutes. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's begin. Firstly, let me close this view and delete whatever we have created here. Go back to plan view now. As you can see, we have 3 levels in this model. Level 1, level 2 here, and also level 3. Each levels have many rooms, so now let's use Dynamo to visualize them in 3D and better demonstrate your program, maybe in a presentation or even in a final report. Let's open back Dynamo now. I'm gonna close this and start fresh so we can be on the same page. Let's tile the view so I can keep track of progress. Here we go. Okay, so the first step to do is to collect our rooms. Let's search for categories and place a note in here. From the drop-down, just select rooms. You can type the name in for quick selection. And then if I do all elements of category, I can then use this second note here to collect the elements from the rooms category there. If I now expand this, you see there we have 92 rooms. However, they are now on the same list, and that's not good enough. We want to separate them, so we have a group for each level. This is because later on, as you saw before, I want to be able to move the levels independently in my 3D diagram view. So the next step is to get the level information of these rooms. Let's do get parameter value by name. This one here. The elements should be our rooms there. That's no brainer. And the parameter name is obviously level. So let's put in here a string node and type in it level. When I connect the name to there, I should get back 92 level names. And yes, I did. Next step, we want to group the rooms by the level name. So obviously, let's do group by key. And then connect the list of rooms here to the list input. The key will be our level names, so I can connect this to keys. If I now just drop in here a quick watch node, I can see that the unique keys are just 3, which are the level names 1, 2, 3 there. And the groups, I have my rooms here in different groups. So group 1 here will be rooms on level 1, group 2 for rooms on level 2, and group 3 there for rooms on level 3. That's all there is to it. Now it's time for us to obtain the parameter of the rooms that we want to color the diagram by. Let's do another get parameter value by name node. This one again, same as that one, but this time the parameter name will be different. I will put in here another string node now. And let's try to go with name for now. So we have room names to be extracted from these rooms. So the name will be the parameter name, and the elements will be rooms that I have grouped from this. When we inspect the output, we have now one list for room names on level 1, the second list for room name on level 2, and the last list there for room names on level 3. So far so good. This watch node here, I can delete it. There's no need for it anymore. Next step, we want to apply another grouping, because now we have to group rooms on each level by their names. So let's try group by key again. Like this. The elements to be grouped will be coming from here, so I will connect it there. And the keys will be our room names. So this one will go into there. You can see there's a warning. It's saying that we cannot use a nested list of keys as the input for this node. But that's fine, I can just continue using this node here. Just have to apply the right level that it should operate on. So for the list of rooms, let's click here, just use levels. Level 2 is fine for now. Let's do the same for the list of keys. And you can see now the warning has gone away. If I now expand this list, still a bit hard to see, so let's put in here a watch node and inspect the groups that we have from this second grouping operation. So now we have the first list for rooms on level 1, the second list for rooms on level 2 again, and these are rooms on level 3. But if I now go into maybe one of these 3 lists, I can see that the rooms have been grouped by name. To confirm this, I can simply copy these 2 nodes there, Ctrl V to paste them, and apply this name lookup on this list of rooms. And you can see now, of course, rooms of the same names are now in the same sublist. So this grouping has worked. Next step is to get the element geometry of these rooms. And there's a note for that, elements.geometry. I can now connect this to here, and it should obtain for me a list of 3D solids that represent these rooms. You can see there I'm in one of the rooms already. Let's press Ctrl B now to switch to the background and do a zoom to fit. Here we go. That's our rooms in 3D, or how their geometry should look like. Ctrl B again will take me back to the graph interface. Let's move this one to here. Moving on, let's bring these solids boxes into Revit as actual elements. To do that, I can do import instance by geometries. Make sure you go for geometries, the plural, not geometry, the single. So by geometries, that's what we need. Now, before using this node, make sure you remember to turn the run mode of Dynamo from automatic to manual, because this is one of the heavy operations, and running this on automatic mode may very well crash your Revit. Okay, let's save the file now, connect this to here, and run the script. That is now done. If I now expand this node, it has created for me 92 imported objects. Each one represents a room. Usually this is good, but not in this case, because we actually want to group rooms by names and then by level. So having just one imported object per room, that means there's no grouping at all. Let's fix this. Let's flatten this list here in a way that will give us the grouping result even after we imported the rooms. So I will put in here a flatten node. Connect to here now. Let's see what turns out. Okay, that gives you 92 solids. So we need to do better here. Let's click on this and select use levels. And then go back to here and select level 3. Run this again. Here we go. Now we still have 92 solids, but they are grouped in the same way that we did the grouping on the rooms earlier. If I now select this and replace the input with this new list, that should give me one imported object per room name per level. Let's try it out. Here we go. So I can see it's working already because instead of 92 solids or imported objects, I now only have 50. Let's see what they look like. Let's go to a 3D view now. And there'll be a lot of things in the way. I can go to VV just quickly and turn off the model categories because we actually want to see just the imported ones for now. And I can also turn off the levels. There's no need to see them now. Here we go. So these are all the imported objects representing our rooms. If I, for example, select this one here, you can see instead of having one object per room, so instead of having 1, 2, 3, 4, 5, 6, 7, 8, I only have now one object like this because these rooms here, they have the same name. And that also happens on other levels. Anyway, by doing this, we seem to have lost one grouping level. If I now go back up here, there's no nesting in this list. This means here I only have rooms grouped by names. So I have to now split this list to group them by level as well. The way to do this is by using list.chop. And this node here, it takes an input list obviously. And it also requires the lengths by which this list should be separated into chunks. That's easy to get. I can just do list.count. We can count the list from this node here. Plug this to here now. Save it. Run it again. When I check out the output, you can see the list has 3 objects. This is another case where we need to use levels. Let's click on here, select levels, and this time let's go for level 4. Because when I go back to this output list there, I can see level 4 is what I want to count things at. Run this again now. And instead of one number, I have now 3 because that's the number of rooms on level 1, that's the number for level 2, and that's the one for level 3. I can now confidently supply this list of numbers to this input port. And chop the list by pressing run again. So now, when I check out this output, you can see there, for list 1, these are all the imported objects on level 1. For list 2, the same thing goes, and the same for list 3. All of these objects are the ones I can now select like this, because they are on level 3. So far so good. So now we have the geometry. The next logical step is to color them by the parameter value, in this case the name of each room. To do so, I need to go back a bit and try to get the room names. We already obtained the names here actually, using this node. And I can see there, these are all the names that I have in the model. Anyway, this is before I grouped my rooms. So now after this step here where I group them, I need to obtain this list again. So let's do Ctrl+C, Ctrl+V on this node there. And then supply the list of grouped rooms to the elements input port. And run this again. Here we go. Now, instead of just a flat list of names on each level, I have actually names of the same value in a list, and then several of those lists under a level. So that's a level category, then the list of names, and then the names in each list. Next step, I want to make sure to get only one value per name per level, because Let's think about this. These 3 rooms here, I want to give them the same color anyway, so there's no point having the same values 3 times. The same goes for something like further down, like instruction there. All of these 5 rooms can get the same color based on the name of instruction. So let's put in here a first item node. Connect to here now. Run this again. And let's see what we have now. Of course, it's getting just the first item in this bigger list. So I have here just anything under level 1. That's not good enough. Let's go for and do use levels. Level 2 should be fine. Let's run this to confirm. And that didn't really work. Let's see where we went wrong. Actually, that seems about right. Well, this is where it's the same problem we have up here. We have things in the right order, but not in the required hierarchy or grouping. I have here 50 imported objects and 50 names. They are in the order of levels. So I have here a few values for level 1, a few next values for level 2, and the last few for level 3. We just have to chop them in the same way we did on this list here, over here. So to do that, I can just copy this list chop node there, and bring it down here. And then use this list to be the things to be chopped. Maybe we can bring these 3 nodes further down to this area. Save it, and then run it. Okay, that's much better now. Now what I'm looking at is all the room names on level 1, all those on level 2, and all the names of rooms on level 3. So this is good to go. Now, the next thing to specify in Dynamo is the list of colors we want to apply to these imported objects. And that's actually easier than the first 2 things here. We can just start from a list of all the unique room names in a model. That list we already have from here, because here we have the unique keys that was used for grouping these rooms right there. So let's see what they look like now. Here we go. So we have here all the room names that are unique on level 1, level 2, and level 3. They are unique because even though here we have 92 rooms, we only have here 50 keys or 50 room names. So the next logical step is to put them into one single list. Let me do flatten again. This time we want to completely flatten out this list. So let's see how that looks like now. Okay, 50 room names again, but this time without nesting or grouping. Let's bring it down to here. And here the next step is to get the unique values from these 50 names. This is because sometimes you have the same room name being used on different levels. For example, here I have electrical on level 1, but there could be another electrical room on level 2, like that one there, or even level 3 like this one. We want to have just one value of electrical, so let's do unique item. Connect to here now. And you will quickly see instead of 50 values, you will get back, in this case, only 28 unique room names. That's good enough for now. Next step, let's count how many there are. I know we can see this, but for Dynamo, to get this number here of 28, we need to put in here a list.count node. And there it is, 28, simply enough. Now, here you may ask, why do I need to get this number? This is because I need to get 28 different colors to color our rooms in 3D. Let's do another node to show you how it's going to happen. We can do color range now. And you can see, for this node to work, to give us a list of colors, we need to specify the value along this range of colors. And that value we can define using a value from 0 to 1. 0 will give us this color on the left, which is red, and 1 will give us this blue on the right. So to turn this number 28 to 28 values between 0 and 1, I can do a number range now. Let's double click again and type in 0 dot 1 dot count. Count here is the number of elements in the range. Connect this to here now. Save it and run it. you will see coming back is 28 values from 0 to 1. When I connect these values to here and run the script, you will quickly see we have now 28 colors coming back. The same names is there for each color, but of course the red, green and blue values are different. That's how we can get different colors. Next step, we want to use these colors here to color our imported objects up here using the room names down here. This is quite a complex operation, and I did try a few ways to use just default Dynamo nodes to do that, but some of the nodes I needed was missing, and that's why I had to use some Python to make it happen. Don't worry though if you don't know Python, because I will include a link to download this whole script in the video description, and this Python node or script will be in this Dynamo file as well. For now, let's begin by typing in Python node, or actually Python script, this one here. When I double click on this, it will open for me the editor. This is a very flexible window. You can just resize it like this, and it's going to work. The main thing is what to type in here. And let me just copy the script that I have made earlier. So just Control C, go back to here, press Control A, delete, and then simply press Control V to paste it in. Here we go. Let's do save changes now. And for the script to work, you need to connect the input data to it. So let's click on this plus sign. We can connect the list of imported objects to input 0, the list of name for rooms in each object to input 1, the list of unique room names to input 2, and finally, the list of colors to input 3. We can then save the script and press run. Here we go. That's done it. If I now go into here, I can see rooms of the same names are having the same color. This is evident here where I have these 3 rooms for the stair. Even though they belong to different levels, they share the same yellow of color there because their room names are the same. We can then make this 3D diagram look much better by applying some displacement. So when I go to here, select all those on the top level, I can go up to the ribbon and click on Create Displaced Elements. That will then group them in a way into a single displaced element, which I can then move up like this. Let's do the same now for the second floor. So select your rooms in 3D, create elements, and move the displaced element up. Let's do the same now for the bottom level as well. This one doesn't have to move up so much. So now you have the choice of also adding the displacement path, which is just a set of dashed lines that you can do from here. Select one displacement set like this, and then on the ribbon you will have this option to add the path. Let's click on this, and now simply click on the edge that you want to see the movement across your levels. How about this edge here? So 1, 2, 3, 4, 5 here, 6, 8, and then another line like that. Sometimes it may make a mistake where it doesn't connect everything, but that's how we can fix it by moving this level just a bit up like that. And maybe this one as well. But there you have a very nice, fully interactive 3D diagram in Revit in no time at all, using just the power of Dynamo and parametric data handling. Of course, you don't have to use just room name. Any room parameter can be done here. So if I go back to this node, or maybe go to a level, turn on properties. If I select this room, for example, under department, that's now project management. And this room over here, it should be of mechanical engineers. If I want to use the department parameter instead of name, I can simply just go to here and change this parameter name to department. Make sure to match the name precisely. So if that's a capital D, make sure that's capital here as well. And now press run again. There you have it. The colors have quickly changed. Unfortunately, the displacement setup isn't preserved, but we can simply do it again like this. And quickly, very quickly reproduce that 3D diagram, but this time based on a different parameter. So now all the circulation spaces are now in red, All the rooms that are usable are now in different colors depending on their department. Project management is about here. Up there you have something else, and so on. Of course, the path you can place back as well, just like we did previously. If you made a mistake, feel free to delete this line. Select and delete it. Again, the bottom level may have a problem catching up, so you may have to move it up as well. And the rest is easy. Okay, if you want to download this Dynamo script and this Revit file for practice, simply go down to the video description and follow the link there. Also, if you enjoy this lesson and want more like this coming every single week, make sure to subscribe to this channel now. For now, enjoy using Dynamo in Revit to make beautiful diagrammatic presentations, and I'll see you in the next lesson.